So this is May June 2023 Unit 1. Question number 2 says a sample of lead contains atoms of three isotopes Pb206, Pb207 and Pb208. The sample is analyzed using a time of flight TOF mass spectrometer. State why all the isotopes of lead have the same chemical properties. In fact, the chemical property is due to the number of electron. So if the number of electrons are same in an isotope, if the number of electrons are same in an isotope, so I would say that their chemical property would be the same. So I can say they have the same number of electrons. So due to the same number of electrons, they are having the same chemical properties. Same goes with the group number as well. Let's
Yes.
say if I ask lithium and sodium, why they have the same chemical properties? So you will say that in an outer shell, lithium has one electron. In the sodium, it also has one electron. So this is the reason they will be having the same chemical property. In fact, we can also write same electronic same electronic configuration same electronic configuration. Because what's the definition of isotope? They have the same number of electron and different number of neutron. So if you can see Pb206, 207, 208, these are the mass numbers. So when you will see the proton number from the periodic table, so it would be the same throughout. Let's suppose I am assuming that the proton number for lead is 82. So it would be 82, it would be 82. Since they have the same number of electron, that's why the chemical property is same. And in 2.2, they are saying give one reason why the atoms must be ionized. If you remember the concept of mass spectrometry, what we used to do, because mass spectrometer only determines the cation. Mass spectrometer only determines the cation, not a neutral atom and not an anion, in fact. So because in a mass spectrometer, we
Mm.
had this one array diagram in which we used to attach negative plate. We used to attach negative plate so that the cation can be attracted towards the negative plate and will go to the detector easily. So what I am supposed to write in this one, this is of only 1 mark. So I can say uh, ionization produces cation by the loss of electron, by the loss of electron. So the cation can be accelerated, to a negative plate. Simple. We are not supposed to write magnetic field attracted towards the magnetic field. No, we have to say to a negative plate. Yeah, we are talking about the plate that we have attached. It's a hollow disk, basically. It's a disk like, and in between it's a hole. So the cation will pass through this hole, and this disk will speed up the cation, and the cation will reach to the detector in a limited amount of time. Otherwise, it
Okay.
will take a lot of time. If we are not going to do this, it will take a lot of time and the determination will be very slow. And in 2.3, they are saying why PB208 positive has a longer time of flight than PB206 and the charge is same. So has a
Mm.
longer time. It's taking longer time. Why?
Do I say it has a greater mass?
Yeah,
But wait,
it
it
has
has, but both ions have the same kinetic energy.
yeah, they have the same kinetic energy. But the thing is that it has a lower speed. Why? Because it has a higher mass. It has a lower velocity, it has a lower speed. Kinetic energy is related to the charge. So the charge is same, so the kinetic energy is the same. But when we look at the mass, so the masses are different. The one is 208, another one is 206. So the velocity of the ion will be lower. So this is the reason it's going to take longer time. So I'm supposed to write both ions have plus one charge. So they would be having same kinetic energy, but the isotope Pb plus 208 has a lower velocity as it has higher mass. Simple. Suggest why there must be no air inside a mass spectrometer. It's a good question, it's a very conceptual question.
Um, is it so when the ions collide, it doesn't collide with air molecules?
Okay, good. Then, as a result of this, what would happen if they will collide with air molecules?
It would change direction of the ion.
Exactly. This is the mass spectrometer. Let's say this is the detector. So the cation travel in a straight line and it can reach to the detector easily. But when the cation will collide with the air molecules, the air particles, as a result of the collision, the particles will not move in a straight line and the determination will become difficult. So that's the reason there must be no air inside a mass spectrometer. So sample will collide with air molecules, air particles. As a result, sample will not move in a straight line. Okay, shows the mass spectrum of the sample of lead. Figure 1 to calculate the relative atomic mass of this sample of lead. Give your answer to one decimal place. So, we have the formula. We have the formula that is, we can say AR is equal to isotopic mass multiplied by abundance. AR is equal to isotopic mass multiplied by abundance. We have to see how many isotopic mass I have. And of course, if we have an isotopic mass, so I would be having abundance as well. So what I would be doing, I would be multiplying the isotopic abundance with its abundance. So I would be getting the answer. Now I have to see the mass of the peak. Let's say I have a peak at 206. I have
Yeah.
a peak at 207. I have a peak at 208. And also the abundances are also given like that. I have to see by extrapolating the line. And then afterwards, I'm supposed to multiply these and then I would be getting the final answer. So AR is equal to AR is equal to isotopic mass. The first one is 206 multiplied by its abundance. So if I can see the abundance, it is supposed to be 2.4, Point 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So one small box is point 2. Yeah. So this is point 5 and this is point 6. So what is supposed to be this number? Yes?
Yes. That's 0.45. Wait, is that halfway?
Yeah. 1, 2, 3. It's not
Oh,
exactly half. So I can say this is going to be uh, 0.46, 0.42, 0.44, 0.46, 0.48, 0.5. So I can say it's 0.46 plus another is 207. What's the abundance for 207? Again, I would say zero point 0.2, this is 0.3, 0.32, 0.34. Yeah, it's 0.34. And the next one is 208. And its abundance is going to be exactly 1. Divided by what? Divided by what? Divided by the total abundance.
as in you add
Divided
all of
by
them
the
up.
total abundance. So the total abundance is what?
So you'd add all of it up.
Yeah, like 0.46 plus 0.34 plus 1.0. What's the total answer?
Um,
Because the formula says divided by the total abundance. So the total abundance is 1.8, isn't it?
yes, yes.
So what's the answer?
Let me just calculate. I got 168.71.
100 and
68.7.
168.7. No, 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 no,
Okay,
no.
let me check.
It is supposed to be around 207 because we have
Oh, I
the
made a
mass
mistake.
numbers.
I
Yeah,
tried again. I got 207.3.
okay, that's the answer. Okay, now I was talking about this question. Basically, it's 2.6. They are saying calculate the length in meter of the flight tube. They have given you the formula kinetic energy is equal to half mv square. V is equal to d upon t. So where they have specified all the things, what is ke, what is m, what is v, what is d, what is t. Just I have to put the values and I have to get the answer. So I would be starting from calculating the mass of ion. I have to get the mass as well. So how can I calculate the mass first? Mass of, and by the way, I have to calculate the final D, like length in meter. D means this one. But for D, I must get V. For V, I have to apply this formula. And for V, I must know the mass. So first of all, I'm going to calculate the mass first. So mass of ion. What the ion they have given? Pb positive, 207. So the mass of ion will be equal to, of course, 207 divided by 6.02 times 10 to the power 23 times 10 to the power 23. Okay, and they are saying mass of ion in kg. Mass of ion in kg. The answer would be coming in grams. So after the answer, I have to multiply the answer with 1000. Sorry, divided by the 1000 because I'm going from grams to kilogram. So directly I can write 1000 over there. So what's the answer for the mass of ion?
Pardon? Oh, the calculation. Um,
Yeah, 207 over 6.02 times 10 to the power 23 into 1000. So what's the answer?
3.44 times 10 to the power of minus 19.
3.44 times 10 to the power minus 19 kg, kilograms. Now I'm going to apply the formula that is Ke is equal to half mv square, like that. So I'm going to rearrange it. 2Ke is equal to half, no, 2Ke is equal to mv square. So 2Ke over m is equal to v square, and v would be equal to under root 2Ke over m. So they have given the value for the kinetic energy, that is what's the kinetic energy? Yeah, 1.565 exponent minus 14. 1.565 divided by the mass, that is the same as we did, and I have to take under root, so I would be getting the answer. What's the answer for V?
I'm calculating now. Is that 2 times 1.565 to 10 to the power of minus 14?
2 times. Okay. Minus 14. No, 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 it's not
What is
minus
that?
14.
No, I can't read the number. Is it 1.565 times 10 to the power of...
Minus 14. Okay.
Okay. 301.64.
Okay. Like I can say in exponential form, it's 3.01 exponent 5 meter per second, as it's the velocity. As it's the velocity. Any other number after 01? What you're saying?
642. It's really long. So I
Okay.
rounded
So I
it.
can say it's 6.
Yeah.
Okay. This is V. This is V finally. And then for the D, V is equal to D over T. So D would be equal to VT. V is 3.016 exponent 8, exponent 5 multiplied by the time, that is 7.460 exponent minus 6 seconds. 7.460 exponent minus 6. Yes. What's the answer?
Um, the answer is 2.25.
Okay, yes. So the answer is 2.25 meter. The answer is 2.25 meter. You know why? Because the unit for the velocity was meter per second and the time is in second. So the second and second cancels each other. The resulting the answer would be in meter. So I can say it's gonna be 2.25 meter. That's it. Okay. Then this question is about magnesium and some reactions of magnesium. Define standard enthalpy change of formation. It's an enthalpy change when 1 mole of a compound is formed from its elements in their standard states under standard condition. So I can say enthalpy change when 1 mole of compound is formed from its constituent elements. From its constituent elements in their standard states under a standard condition. Why the value of the standard enthalpy of formation of magnesium is zero? Of course, magnesium, what's the standard state? What's the standard state for magnesium? The standard state for magnesium is solid. They are saying it's magnesium liquid. So they are
So the
saying why the
answer is
value for the, yeah. So the answer is supposed to be uh, magnesium is not in its standard state. Or titanium can be obtained by reacting titanium 4 chloride with magnesium. Use the data from the table 2 to calculate a value in kilojoules per mole for the standard enthalpy change for the reaction. So it's Hess's law basically, and the data that they have given is related to the formation data. If the formation data is given, if the formation data is given, so the formula is supposed to be product minus reactant. And if the data of combustion is given, so the formula would be reactant minus product. So we have to see what type of data is given. What type of data is given basically. So I'm going to apply the formula that is product minus reactant is equal to delta H, or product side product side is Ti, that is 0, plus MgCl2 is 2 multiplied by minus 642 minus reactant side has TiCl4, so minus minus plus, and Mg liquid is 9. Okay, Mg liquid is 9, so it's going to be multiplied by 2. I'm supposed to put the bracket first to avoid mistakes. This is product side minus its reactant side, or yeah. So minus 2 into 642. Yeah, you can simplify this to get the answer.
Pardon?
You can simplify this. You can solve it to get the answer.
Yes, okay. Minus 719.
So this is minus minus what?
719.
719 minus
Oh,
719.
is that minus 642?
Uh,
As in, oh, 642. Okay, I read the
so
number
you know
wrong. Sorry.
magnesium is also 2. I'm supposed to multiply this by 2 as well, you know.
Oh, I wrote it wrong because I read the number wrong. I'll just try again. Is it? So at the end, is that 9 times 2?
Yeah, 9 times 2.
Oh, okay. Minus 582.
Okay. State the role of magnesium in this reaction. Role of magnesium. This is 0. This is plus 2. So it's changing from 0 to plus 2. It's getting oxidized.
Oxidization.
It's a reducing agent which oxidizes itself is a reducing agent. What's the definition of reducing agent? The substance which reduces other and oxidizes itself. So it oxidizes itself. That's why it's a reducing agent. Simple. Magnesium reacts with acids. Write an equation for the reaction of magnesium with sulfuric acid. So if this is magnesium, when it reacts with sulfuric acid, it forms magnesium sulfate and what? Water or hydrogen gas? Water or hydrogen gas? Yes,
Hydrogen gas?
exactly. When we are supposed to write water, when acid reacts with base, not metal. It's a metal with acid. That's the difference. Give a reagent that can be added to the products of the reaction in question 3.5. State what is observed. Basically, it's a test for sulfate ion because we have magnesium sulfate. When you will be adding barium nitrate, as a result of this, barium sulfate would be produced. And barium sulfate would give you the white precipitate. If you can see the white precipitate, so this is the confirmatory test for the presence of sulfate. So this is of 2 marks. What's the reagent that I'm supposed to add? I would say barium nitrate, and I can see the white precipitate. They're not asking the equation. I'm not supposed to write it down. Let's say in the next part if they would be asking. No, okay. Magnesium can displace copper from copper sulfate solution because magnesium is more reactive, of course. A student pours 25 centimeter cube of 0.25 mole per dm cube copper sulfate solution into a plastic cup and records the temperature of the solution every minute for 3 minutes. At the 4th minute, the student adds 0.5 gram of an excess of magnesium powder and stirs the mixture but does not take the temperature. The student then records the temperature of the mixture at every minute from the 5th minute. So uh, now 3.7 they say draw two appropriate best fit lines on figure 2. So okay. The first line is this one. The first line is this one. And the second line that I'm supposed to draw is this one. Oh my God. Okay. Yeah. And then what they are saying? Use these lines to determine the temperature change for the reaction at the time of mixing. At the time of mixing. Okay, let's see what they were saying. 25, mhm, 25 steam cube of into a plastic cup and records the temperature for every 3 minutes. So 25 centimeter cube, right? So, and at the fourth minute, stirs the mixture. So this is the mixing point at the fourth minute. So, yep, I would say at the fourth minute, this is, mhm. Oh, oh, okay, yep. Now what they are saying, temperature change. So what can I write for this one? The temperature change. Temperature change means that, so the temperature is on y-axis. The temperature change is on y-axis. So this one is 21. This one is 21, right? And if I can see this one, if this is 32 and this is 33. So what is this? 32.2, 32.4, 32.6, 32.8, 33. So this is 32.2, 32.4, right?
Yes.
And I can say it's going to be, it's in between this one, this is like that. So I would say the delta T is equal to, the delta T is equal to 32.5 minus 21. What's the answer?
Wait, repeat that. Minus. Oh, the answer's 11.5.
Okay. So the answer is 11.5. Okay. And then in 3.8, use your answer to question 3.7 to calculate the enthalpy change in kilojoules per mole for the reaction of magnesium with copper sulfate solution. You should assume that, okay, okay, okay. If you could not, okay. So what we are supposed to calculate, enthalpy change in kilojoules per mole. Like enthalpy change means delta H, and the formula for delta H is, the formula for delta H is Q upon N. The formula for delta H is Q upon N, but I don't know the Q, so I would be calculating the Q first, which is MC delta T. So I must know the mass. What's the mass? Of course, we know the mass is equal to volume in this one. So the volume is 25. I'm taking the mass as 25. C is specific heat capacity, that is 4.18. And the temperature changes, I got 11.5. So the answer would be in joules. The answer would be in joules. What's the answer for Q?
The answer is 1,201.75.
200. What's the answer? 200 and
1201.5
1200
and
and one, and then
1.75.
0.75. 25.0 multiplied by 4.18 multiplied by 11.5. I
Oh,
think it's wrong.
1201. So 1201.75.
Yeah, 120 and then
1.75.
yeah, okay. This is joules. And I have to calculate the moles first. So mole is equal to mass, mass, or but I can say in the question they have given us, let me see, the volume and a concentration of copper sulfate. That is this. So concentration times volume. Concentration is 0.25. Volume is 25 divided by 1000. So what's the answer for mole?
The answer I got is 6.25 times 10 to the power of 20 minus 3.
Now I can use that formula Q upon N. Q is this. I have to convert this in kilojoules divided by 1000. So the answer would be 1201 around. So 1201 divided by the moles, that is 0.25 minus 3. So I would be getting the delta H in negative. It's exothermic. What's the answer?
The answer I got is 192160.
192 kilojoules per mole. Okay, that's the answer.